Hello, thank you for attending my virtual talk. My name is Olivia Licata, and I'm a PhD student under Dr. Boishaki Mazumder at the University of Buffalo. In this work, we track the separation distance of multi-hit pairs within nitride systems to reveal insights on field evaporation in gallium nitride heterostructures. Our goal in this work is to establish field evaporation behavior for compound semiconductors in atom probe tomography. Ideally, in atom probe, ions evaporate one at a time. However, in compound nitride semiconductor systems, multi-hit events are unavoidable. Initially, we hypothesized that there would be a correlation between the multi-hit pair separation and the lattice spacing. The logic behind this is that multi-hit pair events arrive within the same pulse, and that many were likely adjacent within the material structure. To test this, our approach was to track multi-hit events and measure their separation in detector space. Our test structure, shown at the bottom right, is an aluminum gallium nitride bilayer. These were prepared via two different growth methods in order to verify that our results are independent of sample growth and run conditions. Regions of interest were taken as slices along the analysis direction. These are shown as 4 nanometer thick green rectangles. The median pair event separation for each major species is plotted along the analysis direction. Each nitride pair maintains a stable median detector separation across the selected regions of interest. Additionally, both the MOCVD and MBE grown samples followed the same trends and were within 0.2 millimeters of detector separation for each species. Aluminum nitrides demonstrated a larger separation than gallium nitrides. This contradicts our initial hypothesis. If the median distances were directly correlated with lattice spacing in the crystal structure, then aluminum nitride separation would not be larger than gallium nitride separation. To understand the influence of this trend, each median value was expanded to show the entire distribution of detector spacing. The following histograms demonstrate the overall tendency for each nitride pair. All distributions are skewed to the right, which is expected since most of the pair events should arrive close to each other, and the ones towards the tail are less common and likely due to noise. A major distinction between the following distributions is that doubly charged aluminum arriving with dinitrogen has 2 distinct peaks. This bimodality was consistent for doubly charged aluminum dinitrogen in all layers and samples. Interestingly, other dinitrogen pairs did not demonstrate bimodality, and neither did any other pair species. The bimodal behavior indicates a combination of 2 types of evaporation mechanisms, resulting in doubly charged aluminum dinitrogen pairs. In summary, we found that pair events followed distinct trends based on pair chemistry. These trends were consistent between the 2 different growth methods, verifying that our findings were not a result of growth method or run condition. The revealed trends did not validate our initial hypothesis that pair separation would correlate with lattice spacing. However, this revealed that there are other major forces influencing the pair separation. We believe that the bimodal behavior found here indicates a combination of correlated evaporation and dissociation events, since the difference in evaporation behavior would lead to different trajectories and therefore pair separation. We are also considering the potential influence of coulombic repulsion at the surface, resulting in larger detector spacing. In our future work, we will validate our hypotheses in multiple compound nitride systems, including indium aluminum nitride and indium gallium nitride, to establish the compound nitride field evaporation behavior. The species-specific and charge-specific nature of our results is promising for a future investigation of potential dissociation paths in these materials. Thank you very much for attending my virtual talk. Please feel free to reach out to me with any questions regarding this work via email. Thank you.